Here. All right. So today we have 6.2 systems with nonlinear. So the deal with this section is going to be it's going to be a lot of similar stuff to what we did last section. Last section was on systems, but it was all linear. So this one involves nonlinear. What it means by nonlinear is that we're just going to see some that have like a x squared in them. So you can see kind of almost every one of these will have at least one of the equations will have an x squared, okay? So the first set of problems here, I think are actually pretty easy. They say state if the given point is a solution. So they give us a point, okay? In this case, -6, 2, and we're checking to see if this is one of the solutions. So if it is a solution, I should be able to plug in the x for x and the y for y on both equations, and it should create a true math statement, okay? So let's check it out here. Let's plug this into our first equation. So I'm going to plug in 2 for y, and I'm going to plug in -6 for x, okay? So obviously we have 2 x's on that first equation. I plugged in -6 for both of them. I'm going to do my PEMDAS here in a second. Okay. So we get -6 squared is 36. I can, actually, I'll go ahead and leave this to do my super thorough PEMDAS. Oops, so that'll be -7 times -6. All right, so I did my exponents. Now I'm going to do my multiplication. So that's -42. And then let's see, 36 minus 42 is -6. -6 plus 8 is +2. And I haven't been writing this left side down, but that was +2 the whole time. Okay, and so does +2 equals +2? Yes, it does. Okay, so that one checks out. All right, but we now have to check it in the other equation, and it has to work for both equations. So now I'm going to plug it into the other equation. I'm still doing the same x comma y here. So it's going to say 2 equals 5 times -6 plus 8. So this one says 2 equals -30 plus 8. And this one says 2 equals -22. So that is not true. And so I'm going to say overall for this problem, the answer is no. Okay, this would be a yes or no question. It has to work for both of the equations in order for it to be true. If it works for one of the equations and not the other, then that is going to be a no. Okay, if it works for neither equation, then that's also a no. So it's gotta work for both equations there. All right. Okay, so let's try it out on number 2 here. So same deal. We'll plug it into the first equation first. So I'll plug it in as x comma y. So we got 15 equals 3 squared plus 6. So 15 equals 9 plus 6. So 15 equals 15. That sounds good. All right, now we'll plug it in the other equation. So that's going to give me 15 equals 2 times 3 squared minus 3. So 15 equals, on this one, be really careful with your PEMDAS. We're not allowed to multiply the 2 and the 3 together yet because we have to do the exponents first. So it's going to be 2 times 9 minus 3. So 18 minus 3. So 15 equals 15. That is certainly true. And so this one is going to be a yes as well. Okay. So if they're just giving you a point to check, that's how I would do it. I would just plug it in. Make sure you plug it into both equations, just one at a time. And as an x comma y, and do your PEMDAS and just see if it's true or not, okay? If it's true on both of them, say yes. If it's not, say no. All right, let's go on to the next one. All right, so solve each system. So now they didn't give us a point, so now we have to solve this for ourselves, okay? So you can technically still use elimination here, but I actually think we're going to be using a lot more substitution. So we know substitution is where we have one isolated variable, right? So we have our y is isolated here. We can take that and swap it out for the y in the other equation. So I'm going to go ahead and do that here. So I'm going to rewrite this second equation as x squared plus 2x minus 3 equals 3x minus 1. So I took that, what y was equal to in one equation, and swapped it out for y in the other equation. And now I'm going to solve this. Now, this is actually a quadratic, all right? It has an x squared. So in order to solve an x squared, we have to get one side to 0. We have to move everything to one side, and then we're going to have to factor, okay? Now, I always recommend that you that you keep your x squared term positive. So I'm going to make a little note here. Keep x squared positive, okay? So if I move x squared to the right-hand side, I have to subtract it over, which means it's going to turn negative. What's going to be much easier for me is to keep it where it is and move this stuff over here. And you can see that that's going to keep my x squared positive. The right side's going to turn to 0. And we have to figure out what's going to go on the left side. All right, so on the left side then, I have 2x minus 3x. So that is going to be negative 1x, which I'll just call negative 1x. Or sorry, I'll just call negative x. And then negative 3 plus 1 is negative 2. All right, so now I need to factor this. So I'm going to have to do a little diamond factor here. So we're going to have to think of two terms that multiply to a times c and add to b. So a times c here is negative 2. B is negative 1, because we're imagining there's a negative 1 in front of that x right there. So we have to think of two numbers that multiply to negative 2 and add to negative 1. I think that would be just negative 2 and positive 1. So we need to split up this middle term here. I'm going to put negative 2x plus 1x. That comes from that x thing. I'm going to rewrite the first and the last term. And then we're going to do our grouping. So I'll group together the first two terms. I'll group together the second two terms. The first group, I can take out an x, which leaves me with x minus 2. The second group, remember, I have to take out something. So in this case, I'm going to take out a positive 1, which will keep this as x minus 2, which is good because then it matches up with the x minus 2 in the first parentheses. All right, so then This factors into, I'll move this up here, x plus 1 times x minus 2 equals 0. Oh. All right, now we have to say what x equals. So I'm going to say for this one, x equals -1, x equals +2. You can set those equal to 0 and solve them if you want, but most of the time on these, you're going to be able to use a little switch trick. So the +1 is going to turn into -1. The +2 is going to, or the -2 is going to turn into +2. We've seen that a lot this year, but we're not done yet, okay? Because our answer on this should be a point, x comma y, correct? But I don't have x comma y here. I actually have two different x's. So I have to plug each of those x's individually into either one of these equations and find their corresponding y values, all right? So I'm going to do those one at a time. You can plug it into any equation you want. To me, the 3x minus 1 looks a lot easier here. So I'm going to say for this one, y equals 3 times -1 minus 1. So y equals -4. And that gives me a point of -1 comma -4, which is to say, when I plugged in -1 for my x, I got out -4 for my y. Now I'm going to plug in the +2. So I get 5. So this point will be 2 comma 5, which is to say that when I plugged in a 2, I got out a 5, okay? All right, man, these are a lot of work. So yeah, stick with me here. Got to do a few more. I actually, you know what I want to do is, in order to help visualize this, since I don't have space here, let's scroll down for today. And I actually want to jump down and do numbers 9 and 10. Let's do that. Okay, so on this one, you can see that they gave us the two equations again, and then they drew the graph for us. Let's not look at the graph yet. Let's go ahead and just solve this one like we solved the last one, and then the graph's going to help us visualize it. So I'm going to take this one right here and plug it in for y over there. So it becomes -x² minus x plus 1 equals -x. All right, I have to get everything on one side. I have to get one side to 0, but I always want my x squared to be positive. So I'm actually going to add everything to the right-hand side here. Since the x squared is right now, it's negative. I'm going to move it over here. So I end up with 0 on the left-hand side. On my right-hand side, these actually cancel out, and I get x squared minus 1. Now that actually does factor. It's actually a special factoring pattern, difference of perfect squares. So we have x minus 1 times x plus 1. Which would mean that x equals 1 and x equals -1. Now I need to take those and plug them back into one of the original equations. I'm going to do the y equals -x because that seems a lot easier. So y equals -1. And on this one, it would be y equals -1. So this point would be 1 comma -1. And this point would be -1 comma +1. Now, do these graphs actually intersect at those points? I would say yes. If you look right here, that's 1 comma -1. And then -1 comma 1 is right there. All right, pretty sweet. All right, let's go and do the next one here. So once again here, we are going to move this right here. So we get -x² plus x plus 2 equals -x plus 3. Once again, I have a -x² on the left side, so I always want to move that until the x² is positive. So I'm going to add x² over here. I'm going to subtract x, and I'm going to subtract 2. Now, in this case, I have -x minus x. Those don't cancel out. That gives me -2x. 3 minus 2 is 1. And then I'm going to move the x² to the front. All right, now we need to factor this. So this one, we're going to have to do our big X thing. So A times C up top is 1. B on bottom is -2. So what two numbers multiply to 1 and add to -2? It's actually -1 and -1. So I'll split up that middle term as -1x minus 1x. And rewrite the first and the last terms. I'm going to go ahead and do my grouping next. I'm kind of just pausing here in case I'm going too fast, in case you guys get caught up. All right, so now my grouping, the first group I can take out an x, which leaves me with x minus 1. The second group, since that first term is negative, I have to take out a -1, which leaves me with x minus 1 as well. So this actually turns into x minus 1 times x minus 1 equals 0. So I got the same parentheses twice. I think you can probably see here that this just means that x equals 1. I'm not going to write that 2 different times because it's the same parenthesis 2 times. So I can just write it once. All right, so that means I only have to plug that in one time. So we have y equals, and I'm going to plug it into this equation right there, -1 plus 3. So that means that y equals +2. So my point would be 1, 2. You can see on the graph there, they do intersect at 1, 2. So that's good. So we kind of see here instance when it could intersect 2 different times. That's why we would get 2 different answers. And then sometimes, as we saw on the number 10 here, it can only intersect 1 time, and then we'll just get 1 answer. So both of those are possible. All right, let's do one more for today, and then we'll have to finish this up on Thursday. These take a long time. Which one looks good? Yeah, I guess let's just do number 4. All right, so we'll start off on number 4. We'll move this over here. So we get x squared plus 4x plus 3 equals -x minus 1. Now in this case, our x squared is already positive, so I want to add everything over to the x squared side. Get the right side to 0. All right, now we got to factor that. So we will do a little x, and we have a times c is 4 up top, and then b is 5 on bottom. It's got to multiply to 4 and add to 5. That'd be 4 and 1. Now we'll do the grouping. First group, I can take out an x, which leaves me with x plus 4. Second group, I take out a +1, which leaves me with x plus 4 as well. So that's going to be x plus 1 times x plus 4 equals 0. So we get x equals -1, x equals -4. I'll plug both of those back into the easier equations. That'd be -x minus 1. So get y equals -1 minus 1. So y equals 1 minus 1. Y equals 0. And then for this one, y equals -4 minus 1. So y equals 4 minus 1. Y equals 3.